So this is homework number 8, chapter 26.4, on page 270 or 713. And so this is 26.4, so not the first section, but second section. 1a, the question says, solve for a, b, c for this 2 over n times n squared minus 1. So we can just multiply, get the common denominators for these parts, and we get this expression here. The only constant term is negative b, so we solve b is negative 2. And then we can see that the n terms, an minus cn equals 0n, so a equals c. So then we can just do substitution here, and we could solve for a and then get c that way. Okay, so we get a equals 1, c equals 1, b equals negative 2. So when we write this part b of this is the more complicated part of it. So I'll just leave that there for a second while I talk about this. So this expression can be equivalent to this expression here. So I want to take the infinite sum of this expression. Okay, so to do this infinite sum, well, I can do it this way. So I'm going to just list out the terms. So this is equal to, and I'm just going to do the first term, n equals 2. So it's going to be 1 over 2 minus 1 minus 2 over 2 plus 1 over 2 plus 1 is 1. Sorry, I'm just going to write it as 2 plus 1. 2 plus 1. Okay, and then as this is just the first term, so I'm just going to sum it up vertically. So it's going to look like this: 1 minus 1 plus 1 over 3. Okay, so that's the first term. Okay, so the second term is going to look like this. When n equals, so this is n equals 2, n equals 3, I get 1 over 3 minus 1 minus 2 over 3 plus 1 over 3 plus 1. Okay, so this is going to be 1 over 2 minus 2/3 plus 1 over 4. Okay, so we can do the next one as well. Okay, and we can kind of start establishing a pattern here. So n equals 4. This is going to be 1 over 4 minus 1 minus 2 over 4 plus 1 over 4 plus 1. Okay, so it looks like this: 1 over 3 minus 2 over 4 plus 1 over 5. Okay, and you can kind of see there's a pattern establishing here. So if we go to n equals 5, it's going to be 1 over 4 minus 2 over 5 plus 1 over 6. Okay, and we can just continue this. This is n equals 6. It's going to be 1 over 5 minus 2 over 6 plus 1 over 7. Okay, so again, this goes infinitely, but we can see that we can look for a pattern. Okay, so this pattern is actually not very easy to find, but notice that we have a minus 1/3 here. Sorry, that was a plus 1/3, wasn't it? That's going to be a plus 1/3 here. We're going to have, so plus 1/3, a plus 1/3, and a minus 2/3 here. Well, that will cancel out. Notice that here we have a plus 1/4, a plus 1/4, and a minus 2/4. Well, that's all going to cancel out. And we also can do, there's plus 1/5, plus 1/5, minus 2/5. Well, that's going to cancel out. And that's going to continue indefinitely, right? So for every term, every row I go down, I'm going to be able to cancel these out diagonally like this. So this sum then ends up looking like this. So the sum is going to be equal to, maybe I'll write it out this, I'm going to write the sum out. The sum as n starts at 2 and goes to infinity of 2 over n squared minus 1. It's going to start like this: 1 minus 1 plus 1/3, which cancels out, plus 1/2, So these cancel out. These, that's a zero pair. So plus all this, this basically plus 0 dot 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 plus, that's going to be, let's say n is equal to 6. Sorry, that n is equal to infinity then. So we're going to be left with, when everything cancels out, we're going to be left with 1 over infinity minus 2 over infinity plus 1 over infinity plus 1, which is really just infinity. So that's what the end of the thing looks like. So and everything in between from here all the way to the last three terms, they're all going to have a sum of 0. Okay, and these terms canceled out. This actually term helps generate one of the zeros. So these terms cancel out. So really all that we're left with is going to be this. So we're going to have 1/2 plus, well, 1 over infinity is 0, minus 2 over infinity is 0, and 1 over infinity plus 1 is 0. So the net sum works out to be 1/2. And this is called a telescoping series because we can actually get rid of or telescope all these middle terms. Now it's not like we can do successive terms. Now these telescope in a pattern, but these terms don't cancel next to each other. We have to actually find terms that are not next to each other that cancel. But in essence, it's still telescopes, and you're left with this term, well, actually with these two terms, but these cancel out, this term, and the last three terms, which end up being 0. So we end up with a sum of 1/2. So that is the sum of that series.